All right, welcome back to the channel. Again, my name's Big John, and we're going to have one more, well, possibly two more, depending on how long this one is just with the coordinates. But at least one more video on land navigation. So what we want to discuss in this video is our coordinate system. Now, you can use lat longe, you use UTM, you can use the military grid reference, MGRS, doesn't matter, whichever one you would prefer. If I was going to choose personally, I would either use UTM or military grid reference because they're simpler. Lat longe, you have to, all right, it's so many degrees, so many minutes, so many seconds, or it's so many decimal places of degrees. With UTM and MGRS, you kind of forget all that. So when you have your quadrangle, and whether it's a, well, when you have your topo map, whether it's a quadrangle of 1 to 24,000 or 1 to 50,000 or whatever, on the outside, it will have this grid. Now, most of them don't have this grid in here. Topo USA gives you that option that they will, when they print you your map, if you want to, they'll print these. Regardless, your numbers are only going to be here, and you could add the grids yourself when you got them. But when you're doing coordinates, you're always going to go east, then north. And you can do different numbers as far as how accurate. Now, this is east, west is here. So we would start in this corner and how they're increasing. So this would be 2,000, 3,000, of course, 4,000. And then north, we would start here and go north in an ascending order as well. Now, this is 1,000 meters. From here to here's 1,000, from here to here's 1,000. A kilometer. So you got 1 square kilometer. Well, that's not very precise. But we can take our scale or our protractor and we can break this down. So let's say, for argument's sake, that we want to know what the coordinates are for the church, this church. Okay, so we're going to east first, then north. So 4,000. So we're going right here. Okay, this is 5,000. Well, it ain't 5,000. And again, we can use a scale. I don't have a scale that'll match it because it's just hand drawn. So we're going to pretend, but we're going to lay our scale up and we're going to say this is 750. Okay, so there's going to be 4 numbers. So our east is 4750. Okay, now we're going to do the same thing, but we're going to go north. So our north is 3,000. Same point. We're going to go up. Let's call it 150. So it's 3,000 plus 150. So it's 3,150. That will get you a point reference within 10 meters. Ain't nobody that good. I mean surveyors are, of course, but what we're going to be doing, that's plenty good. So if you want to tell somebody where to meet, you can say meet me at 4750-3150. They look on the map and they can plot. All right, here's where we're meeting. They can adjust their azimuths and their distances and work their route out to there. By the same token, we could go the other direction, well, just like what we just did. Let's say you tell me I'm going to meet you at grid reference 4750-3150. Now, these have to be the same. If you use 4 here, use 4 here. If you use 3, 3, 2, 2, 1, 1. You can't do 4 and 3. Okay? So you give me 8 numbers, and we're not going to get into codes and ciphers and all that other stuff. But then I can plot that on my map and say, all right, here's where he's talking about. And this is how we're going to get there. So that is the simple way. And military grid reference does the same thing. It's just your numbers aren't going to be, they'll be different. So just pick which one you want. Make sure everybody in the group's on the same page, pun intended. And so that we're using the same grid reference system. And you can either find out your grid reference or give them a grid reference, whichever way you need to do it. And then, of course, it also, it gives you your distance. Okay. Now, we're going to talk a little bit about some of the variables in this. And I should have made me a list, just to be honest, but I wasn't thinking about it. But you remember we talked about terrain features. Let's move our north arrow to here. Guess what? We're going back to geometry. Well, actually trigonometry. Pretend that's 90 degrees. I know I drew it a little crooked. But we have a right triangle. Okay. This is our vertical distance traveled, our horizontal distance traveled. This is our actual distance. So if we measure on the map, then we need to go 300 meters. But we know we're going uphill. Well, guess what? We're not doing this horizontal distance. We're doing this actual distance. We're not doing 300. So that's the map. Our actual distance is 500 meters. And so we have to account for that. And that doesn't matter if you're going uphill or downhill. Of course, it matters if you tote the load. It's a lot easier to go downhill than it is uphill. But you have to allow for this. That's why I'm saying terrain association works easier, because it's very hard by the time you go around trees, over obstacles, under obstacles, uphill, downhill, your pace count's never going to match completely. So don't think that if I give you this grid reference, you're going to hit it dead on. Hopefully you're going to get close enough that we can give a fall recognition signal to each other and link up. But to think I'm going to walk right into your patrol base, you're whistling in the wind on that. So that's one thing you have to be aware of. Second thing is fatigue. The tireder you get, the shorter your steps get. It adjusts your pace count. Heavier load, shorter your steps get. It adjusts your pace count. You have to allow for this. And there's no hard and fast rules. That's why land navigation is not only a science, but it's an art. And the more you do it, the more comfortable you get with it, the easier it becomes. Another thing you can look at is your time that it takes you to get there. Average walking pace for a person would be 3 miles an hour, 3.5 miles an hour, something. 4 miles an hour, you're picking them up and putting them down. That's almost a trot, But broken terrain, you're moving hopefully tactically, and you got a load. So instead of 3 miles an hour, you may be doing 2 miles an hour, and then of course we'd have to convert it to kilometers per hour. And I'll be honest, there's 1.6 kilometers per mile, but I couldn't do the math in my head right now. But if you're doing all this and you figure you're going to go, let's just say you're going to go 1,600 meters or 1.6 kilometers, which is 1 mile per hour, or 1 mile, and you're doing 2 miles per hour, it should take you roughly 2 hours to get there. If 3 hours you ain't there, you either went past it or we just messed up entirely, or something's wrong, But it gives you a rough idea. It also gives you a rough idea of what time you need to leave. If you need to RV with this group, and let's say, we're going to be fancy, we're going to use 24-hour clock. We're meeting here at 0400. Well, if it's going to take me 2 hours, that means I got to leave here at 0200 to get there. I'm probably going to leave at 0100 because I'm going to have listening stops, J hooks, that sort of thing. That time is only time in the travel. That's not stopping to listen. Navigation checks, doing a J hook to make sure nobody's trailing. We'll discuss this with patrols in an upcoming video. But this gives you a rough idea of land navigation. The only way to get good at it is do it. But to me, it's fun. I always enjoyed it. I enjoyed it before I went to forestry school. And of course, it was a big thing because you had to find land lines and you had to find corner markers and all that good stuff. And if you crossed the property line and you started marking timber on this side of the property line, and that landowner seen it, well, guess what? He's measuring every stump every tree you cut, and you're paying him a penalty, and your boss that paid your check is going to be very irate when he paid out a bunch of money to this man because you didn't do your navigation right and you crossed the line. That's also why, if there's more than one of you, it's good to have 3 or 4, at least a couple people checking. 2 people pace count, 2 people azimuth. And then hopefully you got other people that all they're doing is security, because if you're doing your azimuths or you're either using an individual or an object and you're getting an azimuth on it and you're walking to that individual in low light, or you're walking to that object, that's what your attention is on. Your pace count that's what your attention's on. You need somebody else that their attention is danger areas and pulling 360-degree security. That's why lone wolves ain't gonna last too long if it gets bad. It's gonna take more than one. And the biggest problem most people have starting out, they don't trust their compass. They get a little turned around, and I'm here with my hand raised. I've done it. I've argued with my compass. My compass has always been right. I've always been wrong. They're overly optimistic on the distance they can cover, the time they can cover, and what they can carry. Pastor Joe Fox said when he was in the service, I think we was going through the Q course for Special Forces, the saying was, you don't be late, last, or light. You're never late, never last, never light. In other words, they tell you your pack's got to be 45 pounds. When you get where you're going, you better be 45 pounds. If we're going to link up here at 0400, if you get here at 0500, that ain't no good. So I hope this helps. Like I say, if nothing else, to me it's fun. Get out in the national forest and get you a topo map and just play with it, So comments, questions, criticisms, put them in the box. If I can help you, let me know. Subscribe, all that mess, if you think this is beneficial and people could get help from it. Otherwise, I'll see you on the next video. Thank you very much.